Explore. The James Webb Space Telescope, JWST, is the largest and most powerful space telescope ever built, designed to explore the mysteries of the universe in infrared light. It was launched on December 25, 2021, and reached its final orbit at the second Lagrange point, L2, about 1.5 million kilometers from Earth, on January 29, 20221. The JWST has a primary mirror of 6.5 meters in diameter, composed of 18 hexagonal segments that unfold in space. It also has a sunshield the size of a tennis court that protects it from the heat and light of the Sun, Earth, and Moon. The JWST has 4 scientific instruments: a near-infrared camera, a near-infrared spectrograph, a mid-infrared instrument, and a fine guidance sensor, near-infrared imager and slitless spectrograph 1. The JWST's main goals are to study the formation and evolution of galaxies, stars, and planets, to investigate the physical and chemical properties of planetary systems, to examine the origins of life, and to test the laws of physics and cosmology 1. Some of the exciting discoveries that the JWST has made so far include: 1. Detecting water vapor in the rocky planet-forming zone of a young star system called PBS 702. 2. Capturing extraordinary images of the iconic Ring Nebula, a dying star that expelled its outer layers into space, revealing its complex structure and colorful glow 345. 3. Observing the earliest galaxies in the universe, dating back to less than 500 million years after the Big Bang 2. The James Webb Space Telescope, JWST, and the Hubble Space Telescope, HST, are both powerful space observatories that explore the universe in different ways. Here are some of the main differences between them. 1. The JWST observes primarily in the infrared part of the electromagnetic spectrum, while the HST observes mostly in the optical and ultraviolet parts. 1. This means that the JWST can see through cosmic dust and reveal hidden objects or formations that the HST cannot. 2. The JWST has a much larger primary mirror than the HST, 6.5 meters versus 2.4 meters. 2. This gives the JWST more light-collecting area and higher resolution, allowing it to peer farther back in time and space than the HST-34. 3. The JWST is located much farther away from Earth than the HST, about 1.5 million kilometers at the second Lagrange point, L2, versus about 550 kilometers in low Earth orbit. 3. This means that the JWST is less affected by Earth's gravity, heat, and light, but also more difficult to service or repair. 31. 4. The JWST has a shorter expected lifespan than the HST, about 10 years versus more than 30 years. 4. This is because the JWST has a limited amount of fuel to maintain its orbit and attitude, and also because its sunshield and instruments are exposed to harsh radiation and micrometeoroids. 34. Both telescopes have made or will make important contributions to astronomy and science, but they are not direct replacements for each other. They are complementary tools that help us understand different aspects of the cosmos. 1. The James Webb Space Telescope, JWST, has made many amazing discoveries since it began its scientific operations in mid-2022. Here are some of the highlights. 1. It detected water vapor in the rocky planet-forming zone of a young star system called PBS 70, showing that a water reservoir is available for terrestrial planets that might be coalescing there. 1. 2. It captured extraordinary images of the iconic Ring Nebula, a dying star that expelled its outer layers into space, revealing its complex structure and colorful glow. 1. 3. It observed the earliest galaxies in the universe, dating back to less than 500 million years after the Big Bang, and found evidence of dark matter and reionization in their formation and evolution. 1. 4. It discovered a new type of supernova that is powered by the decay of radioactive nickel-56, and that produces a bright flash of light followed by a long-lasting infrared glow. 1. 5. It measured the atmospheres of several exoplanets, including some potentially habitable ones, and found traces of molecules such as carbon dioxide, methane, water, and ozone. 1. 6. It revealed the hidden details of the southern Ring Nebula, a planetary nebula that was previously obscured by dust, and showed that it has a complex shape and a rich chemical composition. 7. It studied the Pillars of Creation, a famous star-forming region in the Eagle Nebula, and found that they are actually being destroyed by powerful stellar winds and radiation from nearby massive stars. 8. It imaged a collection of 5 galaxies that are gravitationally lensed by a massive foreground galaxy cluster, creating a cosmic mirage that magnifies and distorts their shapes. 9. It witnessed the birth of a binary star system in the Orion Nebula, and showed how the two stars interact with each other and their surrounding gas and dust. 10. It mapped the magnetic fields of several active galaxies, and revealed how they affect the jets, disks, and winds of supermassive black holes at their centers. 11. It explored the interstellar medium, the diffuse gas and dust between stars, and showed how it is shaped by stellar feedback, turbulence, and chemistry. 12. It monitored the variability of several types of stars, including pulsating variables, eclipsing binaries, flaring stars, and supernova imposters, and learned more about their physical properties and evolution. These are just some of the amazing discoveries that the JWST has made so far. There are many more to come as it continues to observe the universe with its unprecedented infrared vision. The James Webb Space Telescope, JWST, has many future goals that will advance our knowledge of the universe and its wonders. Some of the main goals are: 1. To study galaxy formation and evolution in the early universe, and to understand how galaxies change over time and interact with each other and their environments. 123. 2. To study star formation and stellar feedback in various types of galaxies, and to reveal how stars produce the chemical elements that make up everything we see. 123. 3. To study planet formation and planetary systems around different types of stars, and to characterize the physical and chemical properties of exoplanets, especially those that might be habitable. 123. 4. To study the origins of life in the universe, and to search for biosignatures or signs of life in the atmospheres of exoplanets. 123. 5. To test the laws of physics and cosmology in the extreme conditions of the universe, and to probe the nature of dark matter, dark energy, gravity, and spacetime. 123. These are some of the ambitious goals that the JWST has for the future. It will also be open to new discoveries and surprises that might challenge our current understanding of the cosmos. Thanks for watching this video. If you enjoyed watching this video, please like and subscribe.